Have you ever felt a chill run down your spine while reading about a scientific breakthrough? It sounds strange, right? Science is supposed to be about logic and reason. But what if I told you that some of the most profound discoveries in physics are so bizarre, so counterintuitive, they sound like something straight out of a horror movie? Today, we are diving deep into the world of physics to uncover 5 experiments that will challenge your very understanding of reality. These aren't just thought experiments. These are real events that blur the line between science and the supernatural. Get ready, because things are about to get spooky. Let's start with a concept that even Albert Einstein, one of the greatest minds in history, found deeply unsettling. He called it spooky action at a distance. Imagine you have 2 coins and they're magically linked. No matter how far apart they are, one in your hand, the other on the moon. If one lands on heads, you know instantly, without looking, that the other has landed on tails. That's the basic idea behind quantum entanglement. For decades, it was a theoretical debate. Was this spooky connection real, or was there some hidden information we just couldn't see? That all changed in 1971 with the Berkeley experiment. Physicists John Clauser and Stuart Friedman decided to put this spooky idea to the test. They created pairs of entangled photons, particles of light, and sent them flying in opposite directions. They then measured their properties, according to Einstein's classical view. The results should have been predictable, following local rules. But that's not what they found. The results were spooky. The particles behaved as if they were communicating with each other instantly, faster than the speed of light, perfectly coordinated no matter the distance. The Berkeley experiment confirmed that quantum entanglement is real. Our universe is fundamentally interconnected in a way that defies common sense, proving that reality is far stranger than even Einstein was comfortable with. From the mind-bending world of quantum mechanics, let's turn to a phenomenon that seems to leap from folklore into our world: ball lightning. Imagine a glowing sphere of light, anywhere from the size of a golf ball to a beach ball, floating silently through the air during a thunderstorm. It might drift through a closed window, hover in a room, and then vanish with a pop or a bang. For centuries, these stories were dismissed as myths or hallucinations. Scientists struggled to explain them because they're so rare and unpredictable. How can you study something that appears for a few seconds and then disappears without a trace? Despite thousands of eyewitness accounts throughout history, ball lightning remains one of physics' most baffling mysteries. The reports are incredibly varied. Some say it's silent, others say it hisses, some describe it passing through solid objects, while others see it bounce off walls. This lack of consistent data makes it nearly impossible to create a reliable scientific model. Researchers have tried everything to replicate it in the lab, from microwave ovens to electrical sparks in silicon, with limited success. Ball lightning challenges our current understanding of plasma physics and atmospheric electricity. Is it a purely physical phenomenon we just don't get yet, or is it something else entirely? The fact that these spectral orbs can appear in our homes, uninvited and unexplained, is a terrifying reminder that nature still holds secrets we are nowhere near understanding. So we've established that particles can be spookily linked across vast distances. But what does that really mean for our reality? Quantum entanglement isn't just a party trick for photons. It is a fundamental property of the universe that forces us to question everything we thought we knew about space, time, and information. The bizarre correlations between entangled particles aren't just weird. They're useful. This is the technology that powers the next generation of quantum computing and uncrackable cryptography. By harnessing this spooky action, we can create computers that solve problems impossible for even the fastest supercomputers today. But here's where it gets truly terrifying. The act of measuring one entangled particle instantly changes the state of its partner, regardless of the distance between them. This is known as the observer effect, and it implies that reality isn't a fixed, objective thing out there. Instead, it suggests that reality is a participatory process. The universe, at its most fundamental level, seems to respond to our observation. This non-locality, this interconnectedness, challenges the very foundations of classical physics. It suggests a universe that is holistic and entangled in ways we are only just beginning to grasp. The idea that simply looking at something can change something else on the other side of the galaxy is a profoundly unsettling thought. It makes you wonder what else is connected in this invisible quantum web. The weirdness of the quantum world doesn't stop with entanglement. In fact, that's just the tip of the iceberg. Quantum mechanics is a whole field of study that seems designed to make us uncomfortable. Take the Heisenberg uncertainty principle. It states that you can never simultaneously know the exact position and momentum of a particle. The more you pin down its location, the less you know about where it's going, and vice versa. It's not a limitation of our tools. It's a fundamental rule of the cosmos. There is an inherent fuzziness to reality. Then there's Wheeler's delayed choice experiment, which takes wave-particle duality to a whole new level of strange. We know that particles like photons can act as both a particle, a tiny ball, and a wave, a ripple of energy. This experiment showed that you can decide whether a photon will behave as a wave or a particle after it has already passed the point where that choice should have been made. It's like the universe reaches back in time to change its past based on a future measurement. This experiment fundamentally breaks our linear understanding of cause and effect. Quantum mechanics shows us a reality that is uncertain, probabilistic, and seemingly capable of retroactive causality. The solid, predictable world we experience every day is just an illusion, a high-level summary of a deeply bizarre and terrifying quantum foundation. For our final point, we're going to look at experiments and events, where the line between hard science and the supernatural becomes almost completely blurred. While not all of these are strictly physics, they push the boundaries of what we consider possible and challenge our scientific worldview. Consider the Skull experiment, a series of conducted in the 1990s that were rigorously investigated by members of the Society for Psychical Research. The investigators reported witnessing phenomena they couldn't explain: levitating objects, dancing lights, and even apports physical objects materializing out of thin air. One of the most famous was a pristine copy of the Daily Mail newspaper from 1944. Was it a trick? The investigators couldn't find any evidence of fraud. Then there are real-world events that sound like science fiction. In particle accelerators like the one at CERN, physicists regularly create antimatter, the mirror image of normal matter. When matter and antimatter meet, they annihilate each other in a burst of pure energy. We are literally creating and destroying tiny pieces of a shadow universe in a lab, and consider the bizarre case of the mad gasser of Mattoon from the 1940s, where an entire town was gripped by fear of a phantom attacker who would spray a paralyzing gas into their homes. Was it a real chemical attacker? A case of mass hysteria fueled by wartime anxiety, or something stranger? These examples, from quantum weirdness to historical enigmas, show that the edge of our knowledge is a very scary place. They remind us that the universe is far more mysterious and terrifying than we can imagine. So, from particles that communicate faster than light to ghostly orbs of lightning and experiments that seem to rewrite the past, we've seen that physics isn't always about neat equations and predictable outcomes. Sometimes it is about staring into the abyss of the unknown and finding that the abyss is staring right back with a spooky, quantum-entangled wink. What do you think is the most terrifying concept we talked about today? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey into the weird side of science, don't forget to like this video and subscribe for more adventures into the unknown. Stay curious.